So you want to find the volume for the cylinder x squared plus y squared equal to 25 between plane z equal to 8 and x plus z equal to 8. You know this is lower surface because this is z equal to 2 compared to here the z-intercept is 8, so this is upper surface. So lower surface will be a lower limit of your z, upper surface is a upper limit of your z, and you know the volume is triple integral dv. So dv, we can use the dz, because if your solid is parallel with z-axis, then we integrate respect to z. First, so dz, and then the dA can be your dy dx or dx dy. And you have the cylinder, so the projection, like this example, the projection is a circular region where the r is phi. That's why we use if 2D, we said this is a polar coordinate, but the polar coordinate in 3 dimensions, so this will become cylindrical coordinate. Cylindrical coordinate where, so dA, you change it to, you got dz, lower limit of z, which is the lower surface, which is z equal to 2, up to the upper surface, which is z equal to 8, 8 minus x, dA using polar, which is r dr d theta. R dr d theta. You need the limit for r, limit for theta. And then you said no questions, right? Meta, what is the limit for r? Meta, are you around? What's the limit
Yes,
for the
doctor.
r here? Here from x squared plus y squared equal to 5, r is 0. So what's the limit for to integrate respect to dr here?
0, doctor.
0 to
0
0?
to 5.
Yes, correct. 0 to 5. And then theta, like this one, only r change to 5, so the limit for r is 0 to 5. How about theta Muhammad Akasa? What is the limit for the theta? Your cylinder is full, so you got the full circle. Your cylinder is x squared plus y squared equal to 25 in the in that exercise, so r is 0 to 5. How about your theta Muhammad Akasa?
8.
Theta, limit for theta, limit for theta from polar coordinate. Now we got the polar coordinate in 3 dimension is a is a cylindrical coordinate. Just now in the video, this example already says if your region r is only first quadrant, theta 0 to pi over 2 is cover first, and the second theta 0 to pi. If your circle cover all the full circle, you rotate one cycle, what is the theta? Already on the slide here, here you will see theta from where to where?
Pi.
Pi until here only.
2 pi.
2 pi. That's why. So when you're watching video, whether effective or not, whether you watch or not, even though we give you the video and then the PDF then when asked any question, you said no question. So give back similar question, you cannot answer. So make sure you are active learning. So you already know the limit, so please please do it by yourself. Can you do it? This one, can you solve it? So that's why you watch people drive, and if or you drive yourself is totally different. So you have to drive by yourself. You just watching, and then ask you back. You okay, ask you any question, you said no question, but okay, when ask you again, you cannot answer. Okay, this is z equal to 2 from z equal to 8 minus x. So dz r dr d theta. So you have the polar coordinate in 3 dimensions. This is so-called cylindrical coordinate. Okay, cylindrical coordinate in solving triple integral. Okay, first of all, you integrate respect to z first. So you have okay r okay r okay when you integrate respect to z, r is constant. That's why okay r is constant. That's why you can factor outside of dz. So this one you got z. So z limit for z is 2 up to 8 minus x. So you have r dr d theta here. So plug in, later on plug in upper limit, deduct lower limit. So you have 8. Okay, and then when you're in cylindrical coordinate, x you have to change it to r cos theta. So this one is r cos theta. So you got 8 minus r cos theta minus 2. Okay, outside you got r dr d theta. So expand it, okay, and then integrate respect to r. Lastly, integrate respect to theta. So you have 8r minus, oh, so 8 minus 2, you got 6. So you got 6r. 8 minus 2, 6. So time r, you got 6r. So minus r squared cos theta. Okay, so now is dr d theta. So now integrate respect to r. So you have 6r squared divided by 2 minus r cubed divided by 3. This is cos theta. Okay, d theta, limit for r from 0 to 5. So this is 3. This one 3. So you have 3 and then 5 squared minus 5 cubed divided by 3, and then cos theta. Substitute 0, everything 0. So you got the theta here. Okay, and then okay, you simplify. Lastly, integrate respect to theta. Okay, or you can directly from here using your scientific calculator. Where is it? Okay, let's say you from this step, if you're directly using your scientific calculator, so you got okay 5 squared is 25. So you minus okay 5 cube 5 cube divide 3. Okay, theta you have to change to x, okay, because your calculator only accept the variable in x for the integration. So you got cos okay alpha x, close it. Okay, so from 0 to 2 pi. So 150 pi. Okay. Question, where's the question B? So we get the answer is 150 pi. Okay, check the question 3B. So 150 pi, okay, they put the unit cube. So for the question 3C, z, okay, limit for z 0 to 3 are 0 to 2 theta 0 to pi over 2 because in the first octant. So you got dz and then r dr d theta. So integrate one respect to z, you have z. Then r dr d theta. Okay, plug in upper limit of z minus 0. So the left is actually you have 3. Yeah? So I factor out 3. 0 to pi over 2. 0 to 2. So you have r dr d theta. Integrate r dr. Okay, you have the r squared divide by 2. I factor outside. So limit of r 0 to 2. So d theta. Plug in upper limit 2. You have 2 squared is 4. So you got 3 over 2. Okay, factor out the 4 here. Then integrate 0 to pi over 2 d theta. So simplify. This is 6. So integrate 1 d theta. You have theta. Limit from 0 to pi over 2. So the answer is 3 pi. Question 3C. 3 pi. So question 3A. Paraboloid z equal to x squared plus y squared and plane z equals 16. So from the lower curve, which is z equal r squared until top surface z equals 16. So limit for z r squared to 16. Plug in z equal to 16 into the parabola equation z equal x squared plus y squared. So you have x squared plus y squared equals 16. R is 4. So limit for r 0 to 4. And theta, you have the full circle, theta 0 to 2 pi. Then you just evaluate it. The volume, you have 0 to 2 pi, r 0 to 4. Z from r squared until z 16. So you have dz r dr d theta. So you integrate one respect to z, you have z. Put up limit r squared to 16. So r dr d theta. So you have upper limit 16 minus lower limit r squared. Outside multiply by r and then integrate respect to dr. Lastly, integrate respect to d theta. So expand first before you integrate respect to r. So you got 0 to 2 pi, integrate 0 to 4. You have 16r minus r cubed, dr d theta. So 0 to 2 pi. So you have 16 r squared divided by 2 minus r power 4 divided by 4. 0 to 4. D theta. Simplify first. Lastly, integrate respect to theta. This one you simplify it. This is 8. So 8 and then 4 squared minus 4 power 4 divided by 4. So you got 4 power 3. Plug in 0, everything 0. Lastly, d theta. And then you can simplify first. This one 8 times you have 4 squared minus 4 cube. The answer is 64. You got 64 0 to 2 pi d theta. Okay, this one is theta. Plug in 0 to 2 pi, you get answer is 2 pi. It is 64. Integrate 1 respect to theta is theta. 0, and then put up limit 0 to 2 pi, you got 2 pi. So 64 times 2 pi. So 128 pi. Okay, this is question 3A. Where is it? 128 pi unit cube. So if you don't put unit, doesn't matter, we won't deduct you. You have, okay, when you sketch, okay, the volume the solid is actually side is cylinder, so you have cylinder. Below is xy plane. Okay, so below is z equal 0. Okay, above is paraboloid. So mean your cylinder, mean the surface is actually this one. It's actually, you have a cylinder, and then paraboloid is inside the cylinder. Dig out the paraboloid. Take out the paraboloid volume. Okay, the cylinder actually and then how you know they cut at where? You know, okay, how to know the paraboloid and the cylinder intercept at where? Then you solve, okay, you have the paraboloid z equal, paraboloid is you have your paraboloid z equal x squared plus y squared. You have z equal x squared plus y squared, and then cylinder is x squared plus y squared equal to 4. This one, okay, z equal to 4. That's why, okay, it's actually paraboloid and cylinder intercept. This is at z equal to 4. Z equal to 4. So, okay, if you use triple integral, they say bottom is, okay, flat, okay. So mean is a bottom is a flat cylinder, cylinder cut by the surface, okay, xy plane, which is z equal to 0. That's why, okay, you dz first, so z equal to 0. Top, okay, bounded above, so mean the upper surface is this one, paraboloid. Okay, paraboloid is z equal to x squared plus y squared, which is z equal r squared. Okay, and then the projection is cylinder, is circle, right? Okay, where the circle is where x squared plus y squared equal to 4, so r equal to 2. And then so, okay, the projection r is circular. We use okay, r d theta. So limit of r 0 to 2, okay, limit of theta 0 to 2 pi. So you think of okay, we will look, okay, the only changes is at limit of z. Now z 0 to r squared. Z, okay, 0 to r squared. Okay, if you third, okay, example, you find volume of the paraboloid. Limit for your z is 0 to r squared. Okay, this one, sorry, uh, for paraboloid, not 0 to r, 0 to r squared is just now this example. 0 to r squared, because bottom is flat, upper is a paraboloid. Then if you find volume of the paraboloid, bottom is z equal r squared, upper is z equal to 4. Okay, if you find the volume of the cylinder, okay, bottom is flat, z 0. Top also flat, z equal to 4. Okay, so these three example, their projection are circle with radius 2 unit. So the only difference is, okay, mean the limit for r and theta for this example 2, 3, 4 are same, except your limit for z. For, okay, cylinder limit, okay, lower surface is z0 to z4. Okay, and this one you obtain 16 pi. 16 pi. Okay, and then, okay, volume of this cylinder, if you deduct volume of the paraboloid here, volume for the paraboloid they obtain is 8 pi. Okay, this question is actually the paraboloid is inside cylinder, and then you dig out the paraboloid, so you left this one. So you take the volume, okay, in example 2, which is 16 pi, you minus, okay, volume of the paraboloid, they obtain 8 pi, you should get the answer 8 pi. Okay, and if you do it, okay, using triple integral, here, the limit 0 to r squared, 0 to r squared. If, okay, your cylinder limit 0 to 4, if paraboloid is r squared to 4. So you have the PDF file, you can have a compare there. Then think it why like that. If you never think, you just follow, then you can never answer the questions. So Hadi, you have the PDF file, right?
Yes, doctor.
Yeah, you can have a compare there. So you see limit for r theta are same, is only the changes of limit of your z, because of you have to understand what are the solid that remain. This question, the solid that remain is actually a cylinder, dig out the paraboloid, the intercept at z equal to 4. So bottom is flat, z 0. Okay, upper part is a paraboloid, which is z equal r squared. And then the projection still circle with radius r is 2. Okay, and then you can have a try at, I think, same thing. This question is same with my example 4. So you no need to do a same. Sorry, this example 3, paraboloid. This one is example 3, exactly same. Okay, 3e is actually my example 4. Bounded by paraboloid z equal r squared, below by the plane, okay, z equals 0, side by cylinder. So bottom is z 0, top is actually, okay, paraboloid. So this one same with the example 4. Okay, so no similar question to do. Unless 4b similar, but in the first octane. 4, okay, okay, okay. But this is paraboloid. Okay, this one similar example 3, that first octane theta 0 to 2 pi. Okay. Okay, you can have a try question 4c. 4c, solid bounded by paraboloid z equal x squared plus y squared, below by xy plane. Xy plane z is 0, and the side by the cylinder x squared plus y squared equal to 3. So this one similar to question 3D. Question 3E is actually the my example 4 in the, okay, lectures. Okay, example 4. So this one similar. It's only we change 4 here to 3. So question 4C. Please look at question 4C. Solid bounded by paraboloid z equal x squared plus y squared below xy plane. So, okay, we look at question 4C. Yeah? So you have paraboloid, okay, like this one. The drawing not sharp. Below is xy plane. You have, okay, first of all, you can draw the cylinder. Cylinder x squared plus y squared equal to 3. Okay, down here, I put here cylinder. Okay, cylinder x squared plus y squared equal to 3. So r is 3. Okay, the cylinder, okay, bounded below by xy plane. So it's flat. Flat. Z equal 0. Okay, and above, okay, is bounded by paraboloid. So your paraboloid. Uh, So it's only the area that I sketch. So mean dig out the paraboloid out. Cylinder, okay, bottom is z0, top is actually bounded by paraboloid z equal r squared. Okay, and the cylinder, you have your cylinder is actually r equal to z3. So can you put up, okay, what is the volume? So, okay, the solid is parallel respect to z. So we integrate respect to z first. Okay, so please tell me what is the limit for the z. Okay, until now, Siti no ashikin. Siti no ashikin. So question
Yes,
4C. What's the limit for the z? Siti no ashikin.
zero.
Yes.
Yes,
Limit for z
z
for question 4C. From where to
zero
where?
to
0 to?
r squared.
Yeah, correct. Thank you. So limit for z from 0 to r squared. The projection is a circle, so we use dA use r dr d theta. Okay, limit for r, Soleha. Limit for r from where to where?
Yes, doctor.
Yeah, limit for r from where to where? Question 4C. X squared plus y squared equal to 3, r squared equal to 3, so r is 3. So what is the limit for r?
0 to square 3.
3. This is called 3. 0 to 3, okay?
So 3.
Yeah. And then soon, what's the limit for theta? Soon, are you around? Limit for theta?
Yes, doctor.
Yeah. Question 4C, what's the limit for theta?
0 to 2 pi.
Yeah, correct. And then you can integrate it for question 4C. It's actually similar to example 4. Okay. So now we proceed to exercise. Okay. Question 4C. 4C, the volume, theta 0 to 2 pi, r 0 to 3. Okay, dz is 0 to r squared. So dA is r dr d theta. Okay, and then let's see whether it's recording. So and then we integrate respect to z, where the r is constant. That's why I factor, okay, outside of dz. So this one, okay, you have z, limit for z 0 to r squared. So you have r dr d theta. So you have the r squared. So because minus 0, you have 0. So r squared times r dr d theta. So total is r cubed. So integrate r cubed, you have r power 4 divided by 4. Okay, you can put up like this. Or, okay, so d theta. So 1/4 we factor out. So 3 power 4 d theta. Okay, then you have 3, 3, 3, 3. Okay, lastly, integrate 0 to 2 pi d theta. This one, you will always get 2 pi. 3 times 3 is 9. So you have here 9. This is 9. So 81. You got 81 over 4. Okay, this one, you integrate, you should have 2 pi. So the answer is 81 pi over 2. Let's see. Unit cube. 4C. Question 4C. Why they get 9 pi over 2? Ask, okay. 4C, why they get 9 pi over 2? What we obtain is 81 pi over 2. Wait, let me check. Solid bounded by paraboloid z equal x squared plus y squared. Below is, okay, below by xy plane, so z 0. Upper part is z equal to x squared, r squared. Side by cylinder, x squared plus y squared equal 3, so r is 3. Nothing wrong. Okay, let me check. Okay, using direct using mapper. Okay, here mid 0. Okay, we got this is r dz. This is dr. The x will change to d theta. Theta 0 to 2 pi. 2 times pi. R is 0 to 3. Oh, I think maybe, no, where's the mistake? Correct? 3. Okay, and then is 0 to r squared. Power 2. Where's the mistake?
Doctor R power
2. 9 over 2 pi. So we got careless mistake in integrating. Okay, 9 here 9 pi over 2. So where's the, okay, see where's the mistake that we integrate. Oh, sorry, here. 3, this is 3 times 3 is 3, not 9. That's why the mistake here. 3 times 3 is 9. 3 times 3, the answer is 3. Here, the mistake here. This is 3. This is 3. So 3 times 3, this is 9. Okay. So you have here 2. So 9 pi over 2. Correct. So the answer is correct. Okay, the mistake is here. 3 times 3 is 3. So another 3 times 3 is 3. 3 times 3 is 9. So 2 pi divided by 4. So you got 9 pi over 2. 9 pi over 2. Okay. So question 4C.